All right, so we're on unit 3A.1. Yay, unit 3. Unit 3 is the longest unit of this entire year. Unit 3 is broken into 3 parts, and these 3 parts will take us to the end of April. Okay. These it should be 85. It's an introduction to like pre-calc, but this should take us to the end of April. But there's 3 sections, 3 parts. We're on unit 3A. There's 3A, 3B, and 3C. Does that make sense? So, how many sections? Inside the units? 6 to 8. It's our longest. So here we go. Yes.
Oh, wow.
All right. So we are now starting with exponentials with natural base. Okay. Exponential with natural base means that our B is now an E. So B for your exponential is an E, and B for your log is now an E. That's what it means by natural base. E is called our natural base. Okay. So that's what we're going to be focusing on is the natural base and its inverse. Cool? Okay, so up first, we have the parent function. So the parent function for e to the x. So this is y equals e to the x. Just like all exponential functions, it's still an exponential function. Like all exponential functions, you have your y-intercept at 0, 1. And then your values are just going to be your e to the negative blah, 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 e to the negative 1, e to the 0, e to the 1, e to the 2. These are the exact values. However, you can't graph them, so therefore you're going to approximate them. All right. E, do y'all remember pi? 3.14? E is like pi. E is just a number. It's approximately 2.72. Okay, that is the approximate value of E. E is a number. It's an irrational number, just like pi. No, not really. In my beautiful presentation that I had made for you, I had a table that's showing you how E was created and that led up to the value of the limit. But as you can see, the world was against me today, and he asked where it came from. Okay. All right. So E is a number. Remember how you accepted pi in 5th grade? You're going to accept E right now. Okay. We're going to accept E as what it is. Approximately 2.72. Got it? All right. So how does it work? You just plot the points and graph. All right. Reviewing, it has the same attributes as all exponential functions. If it's a growth, your domain is going to be from negative infinity to positive infinity. Your range is from 0 to infinity. You do not have an x-intercept. The y-intercept is at 0, 1. You have your horizontal asymptote, which is your imaginary boundary line at x on the x-axis, which is y equals 0. And as x goes to negative infinity, meaning to the left, that's what it's approaching. Yes.
I'm already.
Okay, ask me questions.
What is this? I don't understand, like,
okay. Yes, all I'm doing is repeating stuff. That's why I went fast, because I didn't say anything new. One, we should all be able to say a domain of a function. You should have left algebra 1, being able to tell me what's happening on a function from left to right. If this function does not end from the left and to the right, its domain is from negative infinity to positive infinity. Your range is from bottom to top. What is the lowest your function goes? The lowest this function goes to its boundary line, which is at 0. What's the highest it goes? Infinity. 0 to infinity. That's your range. Okay, that's what your function review was getting you over to. Remember those vocabulary words. Remember domain, range, and identifying those things. Okay, x-intercept. Because I'd never touched the x-axis, do I have an x-intercept? No. My y-intercept. My y-intercept is where do I cross the y-axis at? I cross the y-axis at 0, 1, right? We agree? That is all I did was identify attributes that at this point in pre-AP Algebra 2, we all should be able to do. I asked.
I wish we had the PowerPoint. Do you want us to say that?
No, it has nothing to do with PowerPoint. It's knowledge that you should already have, whether it's written on paper or in a PowerPoint. Next, this part right here, it says, you have a horizontal asymptote. Yes. The only time this horizontal asymptote is going to impact you is if as your x's go to negative infinity. That's because you're not going to realize there's a boundary line until you're heading towards it, right? Because if I'm heading away from a boundary line, will I know it? No. But I only know that there's a boundary line because as x goes to negative infinity to the left, it's getting curved. It's getting closer and closer to that boundary line. Okay? This function is increasing because we read our graphs from left to right. It is increasing. It is 1 to 1 because it passes the vertical line test and the horizontal line test. Correct? It is smooth. There's no breaks, gaps, or asymptotes. That's all we did was analyze the function as is. It's not. I was lazy and I copied and pasted it, and then we're going to change it when we get there. Yep. All right, this time, now we're going to analyze the decay. Your decay means that your base is between 0 and 1. Okay. All right, so your domain, again, did my domain change? No, it's going to still be all real numbers from negative infinity to positive infinity. Did my range change? No, I still have that boundary line that says, uh-oh, can't go past here. X-intercept, does it exist? No, we have the boundary line. Y-intercept, did it change? No. Horizontal asymptote still exists, except now it's from where? When I'm heading in what direction? To the right. So as x goes to positive infinity. So as I'm heading to the right is when I'm going to feel the effects of that boundary line. Okay? Again, your teacher, she just copied and pasted the box and forgot to change increasing to decrease. Okay? It is still 1 to 1. Why? Because it passes the vertical line test and the horizontal line test. It is smooth and continuous. There's no gaps, holes, or blocking along the way. I can take my pencil and trace it all the way through, correct? Along its domain. All right. At the bottom, notice here it says that if you have two exponentials equal to each other, that means that their powers have to be equal. Okay? The powers U, V have to be equal to each other. If the bases are the same, then the powers have to be equal to each other. And this is going to be important to utilize further we get into this. Yeah. Some italicized me. What the Word document did. All right. Now we're going to talk about exponential transformations. We've talked about transformation rules, right? Functions go left, right, up, down. They vertically stretch and compress, correct? We're going to analyze it from the from base equal to E. So from when our base equals E, what does that look like? Well, that looks like this. We would have the transformation rule of f of x equals A times E to the x minus c plus d. Okay. Each piece has a role. Your A has a role, your C has a role, and your D has a role. So it makes it algebra. Well, guys, sorry. So starting off here, when you have your D, that's called a vertical translation. So that means we're going to be vertical. It's our vertical translation. With your vertical translation, if it's plus D, That means you're shifting up. That's what D greater than 0 means, that it's a positive D. That means to each one of your Y values, you're going to add D. Does that make sense? Same rules before. If it's minus D, you're going to shift down. That means to each one of your Y values, you are subtracting D. Okay. Now we're going to look at C. Our C is going to be our horizontal. It's our horizontal shift. So whether we're going left or right, bless you. Bless you. If your C is positive, greater than 0 means the number has to be positive. Does that make sense? Okay. If C is positive, it shifts to the right. Okay. This is where our X's are liars. It's going to look like a negative C, but it's actually a positive C, which means that I'm adding to all of my X's. And that's why I'm going to the right. When C is less than 0, it's going to look like plus C, but it's actually subtracting from your X's, which is going to cause it to go to the left. That's because in the original function, it's already minus a C, and that C is positive. Why did they write the rule that way? I do not know. Okay. I know that there's a movement to change it. That just means that every calculator would have to be reprogrammed through. So I don't know how much that movement's going to happen. All right. Next, stretching and compressing and reflection. So now we're at our A. Your A is what's in front. It's your vertical compression or stretch or reflection. I forgot the C. Vertical. There it is. Okay. If your A is greater than 1, it's a vertical stretch. That means you're going to multiply A times your Y. Okay. If your A is between 0 and 1, it's a vertical compression or a vertical string. You're still going to multiply A times Y. That's how you find a stretch or compression. It's your Y times A. If A is less than 0, meaning that A is negative, it's a reflection across the x-axis. So if your A is negative, you're going to reflect across the x-axis. Okay, so with these rules in mind, we're going to explain what took place to this function. So that says negative. I didn't write much. All right, so to this function, we have f of x. This function, we have f of x equals negative e x minus 3. Okay, and we're going to describe what took place to this function. All right, so we have 3 transformation variables. We have a, we have c, and we have d. Agreed? What is our a in this problem? -1. What is our c in this problem? 3. And what is our d? 0. So each one of these tells me something about the function, right? So a equals -1. What does that tell me? It's a reflection over the x-axis. What does the 3 tell me? That got weird. Hold on. Oh, what are you doing? What are you doing? I just wanted you to erase my ugly S. It's going to go to the right, exactly. So the 3 is shifts 3 units right. And did we have any vertical movement? No. Okay, what these are comparing it to are its parent function. Your parent function is what the first thing we talked about. So these are comparing what's happening to the function to the parent function. So our parent function that we're looking at is, yeah, I call it e to the x, right? So we're going to draw. Oh man, that did not go very smoothly. I can't even tell you how to pretend that's a straight line. Let's try that again. Follow the line. Follow the. That's cool. Parent function, yeah. So our parent function is e to the x. If we look at our original graph that we graphed at the top, underneath our part, it had a graph that looked like this, right? Yep. Drawn to the best of my abilities. Okay. That's what you're manipulating. That's what you're applying these three rules to. So if you reflected and shifted 3 units, what does it look like? I'll let you draw that on there and then we'll resume tomorrow. Okay. So you're reflecting it over the x-axis and shifting it 3 units to the right.